Good morning, everyone. In today's class, we'll just start with the Unit 1 revision. In the Unit 1, we just started with the concept of crystallography. So, you already know this matter. So, here we'll just have a very brief explanation for the students who might have not understood the topic, and the students who are having some doubts regarding the unit. So here we have started the engineering physics with the matter concept, and you know that matter is composed of solid, right, liquid, right, and the third one is gases, and in that gases we had very sub classification. We'll call the sub classification as plasma, right. So here you know that matter is composed of solid, liquid, gases and plasma. We have given our importance to the solid, right. So for engineering purpose we are giving due importance to the solid. So solid, you already know that it has been again classified as two important categories. One is crystalline solid, we discussed, right. Then another is the non crystalline solid. Non-crystalline solids. So solids have been classified in two categories, crystalline solids, and next one is the non-crystalline solid. So again, when you go for the classification, sub-classification of crystalline solid, so in our discussion we had that crystalline solids are again sub-classified into single crystal, single crystal, and then we had the polycrystal, polycrystal. So now this is the subclassification of crystalline solids, and then we have gone for the next important aspect is non-crystalline solid, non-crystalline solids, that is actually known as amorphous. Now, so if we go a little in depth of the single crystal, how you defined single crystal? So very briefly, if someone asks you what is actually single crystal is all about, so you don't know about the atoms and molecules. We cannot see it with our naked eye. What is how the atoms look like, molecules look like, how the arrangement of the atoms are there. So here we need to consider the aspect of what you can say some important parameters. So before that, what is actually the meaning of single crystal? The single crystal, right? You need to imagine now. So in the previous classes, see directly if I want to know the uh, definition of single crystal, so what I can say that periodic arrangement, periodic arrangement, arrangement of lattice points, lattice points, what we discussed, right? So periodic element lattice points. So what is actually the next question arises? What is actually the meaning of lattice points? Lattice points are nothing but imaginary, imaginary, imaginary points. So imaginary points, how that look like? So I'm talking about single crystal. See here. We talk about single crystal. This is the arrangement of the imaginary points. You can just see this. This is the arrangement of imaginary points. So now we'll call such arrangement of the imaginary points as the periodic arrangement. I think that this periodic. Why it is called periodic? You see, after a certain right equal distance, you have the same point here. So here, so lattice points are imaginary points. We'll call such a arrangement of the points is known as the single crystal. Example for this, we have given a lot of example. So you just we can have quartz, right, calcite, and so on. There are different examples, and previously I have given the different examples. Now this is one of the important examples of single crystal. So now this is, I think that you got an idea what is actually the single crystal. So when you talk about polycrystal, what is actually polycrystal or polycrystalline solid? We'll call this as polycrystalline solid or polycrystal. So now this is actually this also periodic arrangement of periodic arrangement periodic arrangement of points whose 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 grains are separated whose grains are separated by well defined boundaries by well defined boundaries by well defined boundaries. So this is only the difference that you have a difference between the single crystal and the polycrystal. So the example that we can give here is that, so when we consider the metals, right? So metals will come under the category of polycrystalline, and there are different examples also. So for your understanding purpose, we'll just keeping this thing into consideration. See, we have started our physics class with this matter. What is matter? Is composed of solid, liquid, and gases. Again, these gases have been classified. Sub-classification is plasma. So, what is actually the meaning of solid? See, we are giving due importance to solid. For engineering physics, the what you are going to study more about solids here now. So that is the reason that we are just keeping aside the liquid and gases. What you can say, the definitions and all. So we just giving concentration to solid. So what is a solid? You already know, a closed, packed, the structure, the elements in which the atoms are closely packed. So we'll call such arrangement as solid. So here the solids are been classified depending upon their what you can say periodic arrangement. They have been again classified as crystalline solids and non-crystalline solids. So or else we just have they have long range and short range classification. So that classification come under the crystalline solids and the non-crystalline solid. So here the crystalline solid again subclassified is single crystal and other is the polycrystal. So here next important aspect that will go for non-crystalline solid. So non-crystalline solid is nothing but we'll simply call that as amorphous. So the other next question arises that what is actually the meaning of single crystal? So here the single crystal is nothing but the periodic arrangement of lattice point. See, we cannot see atoms, we cannot see molecules, we cannot see ions from our naked eye. So in order to understand it right geometrically and also in order to understand it theoretically, what we are doing is that we are just writing it as a periodic arrangement of the lattice points, and these lattice points are nothing but they are the imaginary points. So example of these imaginary points are nothing but we will give an example of quartz and crystal. Here the again see this is about the single crystal. So now what will happen to the polycrystalline solid? So what is actually the meaning of polycrystalline solid? So periodic arrangement of the solids, periodic arrangement of the points whose grains are separated by well defined boundaries. Example for that is metals. So we just give the example of metal and we'll consider that will come under the category of polycrystalline solid. So next aspect that is important for us in order to know what is actually the amorphous. So amorphous is nothing but the lattice points are arranged the lattice points are arranged in random fashion. If the lattice points are arranged in the random fashion like this, right. So like this, if you just take this example, this will come under the category of amorphous, right. So here example, what are the different material will come under the example of this. So for that, example of amorphous is plastic, or plastics, or glasses will come under the category of here amorphous. So here, why we are studying about all this crystalline, see these, they are having their own importance in the engineering and research and development, right, category, industrial purpose also, how we can use the plastics and glasses, how we can use quartz and calcite, how we are using metals. So they are having their own importance. So depending upon their importance, what we have done is that we have indicated, and we have uh, learned some basic definitions of the uh, solids. So now I think that you got an idea regarding the solids, what is actually the solid is consisting of. So in the previous lower classes, you have studied about the solids definition, right? So in engineering, we are just going in depth, depth to the extent that what is the uh, what you can say application of solids to the industrial purpose, where actually we can use the solid for industrial purposes, and how it can be used to a layman, right? Um, that also we have studied, right, in depth in this unit 1. So here, that is the reason that one should know the basic definitions of the solid. So here, we just now we have concluded that the basic definitions of solids and their classification, sub-classifications of the solids. So I think that you got very clear idea regarding the solid, right? Now we'll move further. So in our, what is our aim in studying the unit 1? So our aim is to know the properties of the solids, and particularly we talk about, when I talk about solids, so particularly in unit 1 we'll give our due importance to the metals, right? Particularly we talk about metals, and then we'll learn about the non-metals also, and the dielectric substances, how these dielectric substances are utilized for the engineering purposes. So we need, once a engineering student should know that what is actually the basic concepts of these metals and non-metals, and how this can be used for various applications. So that we are going to learn in the coming units, that how, apart from the metals, semi-metals, and the what you can say non-metals, what how they can be utilized for the engineering student, and how they have been used in the technology. For technology purpose also, we'll use this type of materials that we are studying here. So that is our aim of studying your complete engineering physics in the semester 1. So definitely you will have a very clear idea regarding the basic definitions, and basic theories, and basic concepts of these particular substances that has been given in the syllabus. So each and every unit is given to the engineering student, keeping in mind the usage of the different materials, and that materials, how it can be utilized for a engineering graduate, how the engineering graduate should know the basic concept, such that it can be utilized for various application purposes. So now we just move to the next important topic. So here, you see, in the unit 1 we studied about crystallography. Now once you know that we studied about the crystals, now we just move on to crystallography. Now what is the meaning of crystallography? Graphy is what you can say, study of crystals. How you are going to study about crystals, right? So how you are studying? By application of by application of by application of x-rays, x-rays, or electron beam, or electron beam, or neutron beam. So by incidenting this neutron beam, x-rays, and the electron beam on the crystal, see what we are doing. This is, let us consider this, I am talking about crystal, either that is a single crystal or polycrystal. So I am incidenting the x-rays here, right? So you already know the crystal is compromises of, see, if I talk about this, right? So it has been incident, the x-rays have been incident here. So you get an image, you get certain image, and that image will tell us the exact nature of geometrical nature of the crystal. So that is what the crystallography is all about. So now, before understanding these properties of the crystal, we need to consider certain important parameters. So considering, so in order to know these properties very well, so considering the basic definitions, considering basic parameters, and the things which are involved to study the properties of the crystal. So what are the basic parameters that we are going to learn here? So here the first one is space lattice, second one is your space lattice, or one can say that space lattice is also known as crystal lattice. In the previous section, we just studied about what is actually the meaning of lattice. So here the space lattice or crystal lattice, or we can say what you can say basis. This is about a basis. And the third one that we are going to learn is about lattice parameters. Lattice parameter. In order to understand the properties of the crystal, either that is a crystalline solid, single crystal, polycrystal, or amorphous, whatever it may be, we need to understand, we need to consider some basic parameters. So you just we need to study about this crystal lattice. So what is this crystal lattice is all about? Right? Periodic periodic array of points points, right, such that such that each point each point each point have the same environment, same same environment same environment with respect to the neighboring point neighboring point with respect to the neighboring point in the space in the space. We talk about space, right? So in the space is known as crystal lattice, or we can say that as space lattice or crystal lattice, right? So now these space lattice or crystal lattice, either it may be two dimension or it may be three dimension. And by see next important aspect that we need to understand, basis. So what is basis? If we associate, see what is crystal lattice? This is crystal lattice, right? 2D. We talk about 2D here. I'm talking about 2D. So if you associate the lattice points, lattice points, lattice points with the atoms or molecules, or so we are associating the lattice points with the uh, atoms, molecules, or the ions, right? We are associating. See, if we associate the lattice point with atoms or molecules or ions, right? So, so such type of which are and which are which are whose, or we can say whose orientation. So what you can say that ions. So we'll call such see very simply we can just write it down, basic thing. So this is about the basis. So what is actually, what is the need of studying basis? See, lattice plus basis will give us the crystal structure. So lattice is imaginary point, right? Basis is what? This only for your understanding, brief explanation I'm giving to you. So if we associate it, we'll get the structure of the crystal. So we can obtain the structure of the crystal by assuming the lattice and basis. So once you have understood the crystal structure geometrically, see, very important aspect is that we are considering here. This is completely geometrical aspect. So this is the way that you can know the geometrical crystal structure. Geometrically, you can know the structure of the crystal, right? So now, once you know the geometrical crystal structure, right? Now you had an idea that how this crystal structure is looking like geometrically. So you can apply this thing to understand the different properties of the crystal. So how we need to proceed further, you can just see once we just start with this. So one, yeah, now you had an idea regarding the structure of the crystal. So this was the actually see, this is the assumptions or considerations we need to understand. Why? Because whatever the structure we are going to understand, that is three dimensional, and that cannot be seen from our naked eye. So the things which are not seen from our naked eye, first of all, we need to consider it. This may be the probability, and if we, and that should be proved mathematically. And by proving it mathematically, what we can say, and conducting the what you can say very high microscope, what you can see the extract stack structure basis and the unit cell. You'll understand this when you incident the X-rays or the what you can say the electron beam or neutron beam will be incident on the crystal. So then you'll exactly know the structure of all these aspects, and you will better understand this in the coming sessions. So now we'll just start with the crystal. Now we had an idea geometrically what is crystal structure. So next important aspect that we are going to learn in this particular concept is that we need to know what is actually the lattice parameters. See, we don't know. See, on the earth crust, you'll find different types of crystals, non-crystalline solids, crystalline solids, or amorphous solids. So we need to know that the huge, enormous amount of solids available on the earth crust. So what we can know is that how we can know the exact which particular solid is belong to which crystal. So that for that particular need, what we'll do is that we'll go to the lattice parameter. Now by if I go for two dimension or three dimension, so the smallest geometrical figure that can be obtained by joining these lattice points is cube. See, this is one point, this is the point I'm talking about three dimensional. So for three dimension, the smallest geometrical figure, smallest geometrical figure, geometric figure that is obtained, right? Geometric figure is your cube, or you can simply say it is a cube. So smallest geometrical figure, we talk about three dimension. When you talk about three dimension, right? So crystal is a three dimensional figure, so we talk about three dimensional. So here, now I just take this particular cube, right? Now we'll just take a cube. So this is the structure that we have obtained by joining the lattice point and the basis. You can just see this is the crystal structure what I have obtained. So what we are doing here is that I am extending these lines. You just extend these lines, right? This is considered to be x-axis. You can take for your comfortable means this is x-axis, y-axis, and z-axis. And when you talk about a cube or a cuboid, so now this dimension is nothing but we'll call this as A. This is what your B, and this is your C. So the angle suspended by your here, you find this as some angle will be suspended. This is called alpha, and here you will get the angle as beta, and here you will get an angle of gamma, right? If you take any, so what you can say is that from A comma B comma C denotes the lattice constants. We can say this is what lattice constants, and alpha, beta, gamma are nothing but the crystallographic, 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 crystallographic axes, crystallographic angles, or interfacial, we can say that as interfacial angles. So if you combine, so ABC are the dimensions, right? You know that ABC are nothing but the dimensions of the cube. When you talk about three dimension, what is the area and what is the area of the cube? A cube. You can, everybody know this thing, right? So now if I combine this ABC plus the alpha, beta, gamma, so whatever that combination, this combination we'll call as lattice parameter. This is the geometrical, what is you can say, values that we have obtained, right? So these lattice parameters, why we need to study about this lattice parameter? See here, these lattice parameters are used, lattice parameters are used to know the form and the size, form and the size of the crystal. So that is the need of studying the lattice parameter. Once you say, once someone asks you, so okay, you studied about the crystal lattice, space lattice, or basis. So okay, so crystal lattice basis have been studied to know the, what you can say, structure of the crystal. So what is the use of studying lattice parameters? So lattice parameters are used to know the form and the size of the crystal. Sir, what is the meaning of form and size of the crystal? So that actually will come to know, right? So now see, for example, we'll take an example of cube, or you can say this is cubic crystal which is available on the surface. So here once you should know that 7 crystal systems are available on the earth crust. How many? 7 crystal systems are available on the earth crust, right? We talk about earth crust. So now if you just take one of the crystal, if A is equal to B is equal to C, and alpha is equal to beta is equal to gamma is equal to 90 degrees, if this condition is satisfying, then I can say that I am talking about the cubic crystal. So I say that whatever the thing that we are going to study, that is about the cubic crystal. So that the use of lattice parameters. Like this, you are having different, what you can say, 7 crystal system. So you can just see the different videos for this. Whatever the videos have been taught to you. So that from these videos you can know that what is A is equal to B is equal to C, alpha, beta, gamma. These values will change for the different crystal system. Depending upon these condition, we can say that the given crystal is belonging to either it may be cubic or tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, or triclinic. So like this you will have 7 different crystals, and depending upon these conditions, whatever it has been given to you, depending upon these conditions, we can say that the given crystal belong to which type of which category. So now that is what we have studied in the previous classes. So now we'll move on to the next important aspect. So here, what is that aspect that is very, very important for the next topic that we are going to learn now? I think that you got a clear idea regarding this cubic crystal system. Now we'll just go for lattices. See, we say that there are different lattices which are available uh, in the 7 crystal system. Lattices are nothing but, what you can say, how the arrangement of the atoms, right, constituent particles. See, before we say that imaginary points are nothing but lattices. So here the imaginary points will be replaced by the crystal atoms, molecules, or the ions. So what are the different types of lattices which are available in the, we'll just talk about first of all the cubic crystal theorem. In depth we'll see. Now we got an idea what is actually the cubic crystal system geometrically. Geometrically you got an idea, mathematically we got an idea of that how that can be called as the given, if the given crystal is satisfying the following condition, how we can say that the given crystal is said to be the type of crystal system come under which category. Now here we in the crystal we talk about when you talk about a cubic, so the arrangement of the atoms can be done according to Brevius. Brevius is the name of the scientist which is given, he has given his a way of imagination where he says that there are lattice points, three different lattice points which are available. Points exist in cubic cubic crystal system. So there are three ways through which we can arrange the lattice points or the constituent particles such that the environment about each point will be same. So what is that? First one is a primitive, or we can say very primitive is very small, or we can say that is called simple cubic, which has been represented with the uh, factor p, parameter p. Next one is body centered, body centered cubic, that has been represented with the what you can say uh, letter I. And next one is face centered cubic, face centered cubic. Now this is the three different ways. Either ways you can use these either three ways in order to represent the crystal such that the environment about each crystal is same. What is the meaning of repeatedly I'm saying that there is environment, environment and all? So why? Because we talk about environment, so means what? There will be no change in its properties. See, there will be no change in the properties. If I say there is no change in the properties, so it means that if you can arrange the points or the atoms or the molecules or the ion in this particular fashion, then you will not have any change, you will not observe any change in the properties of the crystal. So geometrically, when you just see that very clearly, if we talk about primitive or simple cubic, so how this primitive look like geometrically, right? So that value will give to you. So here this particular assumption of the primitive crystal, you can just see. If I see what I have drawn is a schematic diagram of a unit cell. This is called a cubic unit cell. What is unit cell? A smallest geometrical figure which is existing in three dimension. So now if you assume that these points are exactly, if the atoms are arranged in this particular fashion, so we'll call such arrangement or such geometrical figure, whatever you are observing, that is considered to be simple cubic Bravais lattice. I call this as a Bravais lattice, Bravais lattice, lattice of simple cubic. You can just see this is a Bravais lattice of simple cubic. Now, if I talk about I or body centered one, so what will the body centered one look like? See here. So again, the atoms or the lattice points are arranged in this particular fashion. Here, if this is arranged exactly at the center, you can just see. If this is arranged exactly at the center, one more lattice point is arranged. So this way also you can arrange the, if you find that atoms or molecules, ions are arranged in this particular fashion, this also will not change the properties of the crystal. And we call this as a body centered one, body centered cubic. It should be very much clear to you. The next one is face center. Last one which is existed in the simple cubic is this one. Here you can just see this is what we can observe this. Now, see again the lattice points are arranged at the corners of the cubic unit cell. Now, apart from this, you can see that when you talk about a cube, so cube will have 6 faces. So each lattice points or the atoms are shaded by the 2 faces of the cube. When I say cube, cube will have 6 faces. So this cube is having 6 faces, and each lattice point is what you can say, each lattice point is being shaded by 2 faces. So this one lattice point is shaded by this 2 faces, 4, right? This is one. This is shaded by, it is like a coin. You can see, you see a coin. In the coin you will find that head face and the tail one. So the coin is one, but there are 2 faces of the coin. In the same manner, the lattice point is one and it is shaded by 2 faces. Understood everyone? So this is the front one, back one, and this is shaded by. Now here you will find at the end here you will find this. So this is shaded by this and this face. This is shaded by the front one, backward, and this is side one. So this is the what you can say. We will call this as face centered cubic. Now, so now this is the one that we have gone for. So this is the basic thing that one should know before understanding the properties. So here, so we just discussed about the here we just today's session. I think that you got a very clear idea at what actually we have done in the unit one. Starting. This is starting. What you can say introduction part that student if you can understand this, then the other part is very easy for you to understand. So here in the last university question paper, last questions asked in the university, asked in university exam. When I talk about university exam, so university exam I'm talking about 2020, right? University exam, the question that has been asked from the unit 1, repeatedly the question which has been asked in the unit 1, right? The first question which has been asked is, what are Miller indices? What are Miller indices? Right? The next question that has been asked is, derive the equilibrium concentration of equilibrium concentration of concentration of Frenkel defect. Frenkel defect. Now these are the two questions which has been asked in the regular and backlog examination. Backlog exam, I'm talking about 2020. So these are the two questions which has been asked in the repeatedly. This second one has been repeated. This has been repeated both in the regular exam. This question has been repeated in the regular exam, also in the supply, or you can say that is the backlog examination. This question has been backlog exam. See, I'm talking about pandemic year, that is 2020. See, this was the question which has been asked in the unit 1. So what are Miller indices and how they are obtained, and derive the equilibrium concentration of Frenkel defect. Regularly and backlog examination, the both cases they have asked us this type of question. So now with this, just I will take an end to the class, today's class. I think that you understood to the conceptual level. I think that you got some idea regarding what is actually the uh, uh, engineering physics of unit 1, why we are studying about the engineering physics, and in today's class we just has a very clear idea regarding the what you can say the basic concept that we are going to learn with what we have learning in unit 1, and that is the about the solids. And in the later section you will understand so why an engineering graduate should understand these concepts and how this can be used for the application point of view. So thank you everyone, thank you for your patience hearing.